Hello class, today I'm going to be performing experiment 9, which is titrating an acid with a base. So first off, I'm going to show you how to set up a titration, and we're going to have our clamp stand. We have our O-ring stand that's connected to the clamp stand that's holding the burette in place. This is our burette. We have our stopcock that's connected to the burette, and then we also have the titration flask, which is the one that we're using is an Erlenmeyer flask. So that's all the equipment. The type of solutions that we're going to be using in this experiment is KHP, which stands for potassium hydrogen phthalate, and then that's our analyte, and then the titrate that we're using is PHPH, which is called stands for enolphthalein. Okay, so when we start to titrate now, when we start to do the titration, we're gonna add the solution. The solution is added here. Not the solution, sorry. The color indicator. The color indicator is to indicate when our acid and base neutralize. So this is our titrant, which is sodium hydroxide. And then our analyte down here, which is the potassium hydrogen phthalate. We have it in there with the color indicator. So we're going to add the solution, which is the sodium hydroxide. We're going to just slightly turn it every so often. You just turn it once to add each drop, because this is kind of like a waiting process. You're kind of patiently waiting for the color to change in the analyte. So we're actually waiting for the stoichiometric equivalence point to be reached. So what the stoichiometric equivalence point is, it's when the acid and the base neutralize, and basically when there's an equal number of moles of titrant to analyte. So this usually, the titrant and the analyte are both clear solutions. So that's why we're adding, that's why we already added the color indicator. The color indicator, which is the PHPH. It'll change the color. The reason why we use this particular color indicator is because it'll change the color of at the pH that's pretty close to the exact same equivalence point. So after we do that, we're gonna slowly mix the flask, slowly mix the flask to see the reaction happen. After that, we're gonna add about partial or like half a drop, because when you get to the end point, you don't want it to go over, so, and see a magenta color. So to add a partial or half drop, you just kind of turn the stopcock slightly till you see like a little droplet begin to form on the end of the burette. And when you see that, you kind of quickly close the stopcock, and then you squirt a bottle of distilled water so the droplet can drop into the flask. After you drop it into the flask, it should turn a light pink color, and that's the result of it. If you drop a full droplet, it'll turn into a magenta color, and then you'll have to start over the whole experiment, which is wrong. And that is called overshooting the endpoint. The goal, like I said, was to calculate the actual concentration of the sodium hydroxide solution that we made. And that's how you visually see that the reaction has ended, when it turns into like a faint pink color. The analyte is the primary standard, and that's how we know that when I say primary standard, I mean that's how we know the concentration and the volume of it. And there's also the secondary standard as well, and that is in the titrate, which is here. And I think that is all I have for you guys. Thank you so much.